Okay, lesson 4. Should you be lost at any point, let me know. I'm also going to try to bring you up to speed for those of us that missed lesson 1, 2, 3. However, everyone at school right now should be on this topic. Some of you done. You're done with it. Okay. You're also done with it. Lovely. Drew, you are also done with it. Okay. Most of you guys there at home on the online session, you must also be done with it. But you're going to see dynamics of different questions as we go on. I'll take my time to re-explain a few other things. And for each question, we will draw all the 3 graphs, whether they ask us or not. I think I've got 4 questions, so we have to run. Again, we spoke about the choice of formulas. Please, that is very, very important. Let me actually bring in a formula page here, because I am not going to help you choose these formulas. You must choose. Okay, let's get the ball rolling as quickly as we can. All right, it starts by reading. A ball A is thrown. Please, I am going to emphasize some words. When you are answering the questions, also emphasize them. A ball is what? Thrown. But how is it thrown? Vertically what? Upwards, from a height h. So automatically we know it has a speed because it was thrown. Velocity of what? 15 meters per second. Look at the same instant, a second identical ball B is dropped. Quickly, does the word drop automatically mean initial velocity is 0? No. Always ask yourself, where is it dropped from? If it is dropped from a stationary point, then initial velocity is 0. But if it is dropped from a moving object, I think I have a hot air balloon somewhere, you're going to see it, then the velocity is not the same. It's not 0. So please always check the word drop. In this case, I'll remind you of this one again. In this case, it is dropped from a height. Whoever is dropping it is not moving. So it means the initial velocity is what? 0. At the same height as ball A, as shown in the diagram below, both balls undergo what? Free fall and eventually hit the ground. Everybody, please define free fall. Quickly, you have 15 seconds. Definitions. Free fall, a ball that is falling freely. Some people are smiling and giving me eyes here. I don't understand. It's not me that said you should define. It's the question. Free fall. What can't you remember? Mali's rolling her eyes, praying I shouldn't call her. It's okay. Wait too. I know you remember. Kind of. Okay. Do you remember? Somewhere there. Somewhere. All right. Free fall. Please understand what learners do is learners confuse a free fall and a projectile. When I say falling is a motion. That's what must come to your mind first. So it's a motion. So what is free fall? The motion of an object that has been given an initial what? Velocity. So free fall, number 1, is the motion of an object that has been given an initial what? Velocity. Oh, my initial velocity and experiences, or let me give you the one that is in the, and is under the influence. It's under the influence. This is how your exam guidelines put it. Of the force of gravity only. Please, we're not going to negotiate these definitions. It's not under negotiation. You must give it what it takes. Number two. So guys, some of this, there are only two definitions you need for this topic. Free fall and projectile. Projectile is an object. All right? Free fall. Guys, do you notice that if you know free fall, check something. If you know free fall, it's actually the definition of both objects. Or both definitions. Look at this. Look at what I'm going to underline. You see that underlined word, underlined statement? That's projectile. Can you see if you know free fall, you know both of them? So free fall is the motion of a projectile. I don't know if it makes sense. The motion of an object. So when I say define projectile, what do you say? An object. That's where you start from. When I say free fall, what do? You add the motion. So it's a two-in-one kind of definition. So put that underlined words, highlight it and call that, I don't know how you're going to do it, but that is, the underlined words is projectile. Underlined. Or underlined phrase or statement, whatever English you want to use. Okay, 2 marks there, we are done. We can't spend 30 minutes on those 2 marks. Number 2, if you need to copy this, you copy. Calculate the time it takes for ball A to do what? Please, you need to read the question to return to its starting point. What does that mean? Ball A was thrown from a height, right? So check what we have about ball A. Try to be creative with diagrams. Ball A went up, right? And came what? Down. Can you tell me the velocities? Before you start as well, direction is key. So let's pick a direction. Upward, as I like to pick the original direction as positive. Are we good? How is your gravity acting, by the way? Gravity is always acting where? Downwards. You've heard that statement. Even people who don't do physics, whatever goes up must come down. So everybody is a physics student. So my G, which is downward, what do you think will be the value? Is it positive or negative? It's negative because we said we are choosing up as positive. Anything going down becomes what? Negative. So what is my answer here? Negative 9,8. Don't worry about the unit for now. Are we okay? All right. What do we know about object A? What were we told? A ball is thrown vertically upward from a height h with a speed of what? 15 meters per second. Great. What do we know? The initial velocity of what? 15 meters per second. And according to vertical projectile motion, if it's from this level back to the same level, what do you think the final velocity would be? Negative what? 15. Please let me know if I've lost. If I lose you here, then we need to sort it out quickly. Please give me a thumbs up if you are okay. It's 15 because it is at the same what? Level. If it is before that level, it's not going to be up to 15. If it is below that level, it will be more than 15. What are we looking for again? Time. Please write down all the things we have. We have VF, we have VI, we have A. This G is also A. So we have VF, we have VI, we have A. Is there a formula? I want us to do this in two ways, option 1 and option 2. All right. Okay, option 1, using everything that you have right now. Can I go to the formula page for you? Please pick the correct formula and substitute. All formulas are right here. Though you don't need to cram them, by the time you work with them more often, you will be able to remember. Which formula are you using? Okay, you substitute and get me an answer. We'll call this 1, we'll call this 2, we'll call this 3. And last week I told you we are cancelling some of this formula, right? Do you know why we're cancelling this one? We're dealing with vertical motion, so it's delta y. You guys said you're using the first one. What's wrong with the second one? I'm just pulling your legs, don't mind me, it's just the first one. Hello, talk to me there. What's your answer? Oh, Nuluazi, yes, we're using the first one. Guys, quickly, put it in the calculator, get me an answer. Let's test your maths. Is your maths alive? Or it's on wheelchair? We should be done, guys. What's your answer? Share your answers with me. Bonalo, answer? Huh? 3,06. Wrong. Answers? Anybody? Very wrong. Wait. You said you got 3, what? Wrong. 3,06 seconds. Correct. Please. 3,06 is wrong. You don't understand why? If you write 3,06 in the exam, we'll mark it wrong. Okay, units, very, very important. So option 1 is to use that formula, right? Which is what? VF. Always you're like, okay, what is this guy saying? What's our final velocity? Negative what? 15 plus, what is this? My good learners, check something. If you do any calculation and you get time as negative, please know that you are wrong. Some of you do very funny things. Therefore, T. This one is not physics. Once you get T as negative, you know what could have happened? Your direction from the beginning might have been wrong. So please, that direction is very important. You said you got what? 3,06. What is the second option? Do you guys know the second option? Do you know the second option? Okay, kind of. You're close. Here's the second option, which you must also know, because certain questions will require that. Look at this. The object was thrown up, right? If I look at this direction alone, what is my initial velocity? This is maximum height. What is the velocity there? 0. But the time it takes to move here will be the exact time. So what I need to do is to calculate this time and multiply my answer by 2. Let's check it. So VF, so this is using maximum what? Height. 0 equals to 15 plus negative that. If I move this, it becomes 9,8t equals to 15. What is t? Don't even worry. 15 divided by what? 9,8. Don't even bring a calculator. Check something. Total time will now be 15 over 9,8 multiplied by 2. I promise you on your calculator, you will get that time as well. So for the second one, we calculated to the maximum height. And we know because it's bouncing back or it's returning to the same level, we can multiply by 2. Bukan, that's what you meant. Beautiful, beautiful. Guys, are we okay? Let's go to the third question now. Thank you. Thank you. Adese, Moleta, Nompi, thank you too. Noluazi 3,06. Oh, beautiful. Derouge 3,06. Lovely. Guys, are we okay with the two options? All right, let's move on. We all okay? You still writing? Okay. Two options. So please know the two options. Very, very important. All right. Let's go for, I think it's one more question here, or two. Just waiting for a moment. All right. Let's look at the next one quickly. Calculate the distance between, this is what some of you do. Your eyes goes to the mark and 7. Yeah, you go to the next question. But let's check. Calculate the distance between ball A and B. I want you to read. It says what? When A is at. What does this when talk about? Guys, when you see when, what are you thinking? There's a word. Just think, guys, don't think physics now, just normal. When will you get home? What am I asking? Time. When? This is talking about what? Okay, let's break this down. Read the question because I'm not going to come back to it. Calculate the distance between what? Ball A and ball B when ball A is at the maximum height. Robertly, did you do something like this? You did this question. Okay, beautiful. So how will you approach this question? Check this. I'm going to break it down in a very, very beautiful way. I have that. And I have that. What's happening? Ball A went up, right? It reaches. By the way, do you think we know the time from here to here? I think we do. It's that 15 divided by 9,8. We got 3,06, right? If we divide that by 2, what are we going to get? 1,53. Beautiful. Do you understand my time? 1,53 seconds. That is the time ball A has traveled. These objects were dispatched at the same time because the question says at the same what? Instant. So someone threw ball A up and at the same time someone dropped what? Ball B. At the same what? Time. It means ball B is also traveling. But the question says when A is at the maximum height. So we are going to look for where B is at this same time of 1,53. Please talk to me if you understand my story. Ball A is traveling. It reaches the maximum height at 1,53. Question says we should calculate the distance between A and B at that time. So how long has B traveled? 1,53. Does that make sense? Yes, talk to me. Let's quickly debug this. Yes, talk to me. Pluto. Your hand is raised. Quickly. I'm waiting. All right. I don't know if you type in or you let me know. You will let me know because your hand is raised and I'm not getting any response. But you let me know. Are we okay so far? What distance are we looking for? That's what we're looking for. So, let's see. From the start, do you think we can get how far A has gone? Maximum height. Do you think we can get the maximum height A has traveled? I think we can. What do we know about A? Let's work together quickly. What do we know about A? We are looking for what? Delta Y, which is of the maximum what? Height. What do we know? And guys, please keep your initial, don't change that. We chose up as positive. Don't change it. Whether the object now bounces, enters the ground, somebody steals it along the way, don't change your direction. Keep it steadfast. What is our initial velocity again? Now, we are focusing on the maximum height. What is the final velocity? Do we know the time from the origin to the maximum height? 1,5. Please, everybody, get me delta y. Write that information down. Don't be lazy when it comes to data writing. Write the data down. It helps you to pick the formula. Sir, please repeat the explanation. My mic is not working. All right. What we said while everybody's trying to quickly walk through, Pluto, is this. The question says, what is the distance between the two objects when A is at the maximum height? So, A was going up, B was coming down, right? So now you would notice it took A 1,53 seconds to get to the top. Also, B is traveling, but we want it to stop when A gets to the top. So we are going to consider that time frame of 1,53, and we need to look for the distance between that. That's why reading the statement is very important. I don't know if that makes sense to you now, Pluto. That when object A is at the maximum height. Give me a thumbs up or a thumbs down if you're still lost. Formula page. Okay. You've written everything down. Quickly pick a formula. Pluto, please talk to me. I'm now checking my screen. Was I able to get to you? All right, I'm not seeing any response. Did she log out? Okay, all right. You have all your details, right? Get me delta y. Good, I like we're using different formulas. Lovely. Bonello, what formula are you using? Number 4. Okay. What formula are you using? 4. 4. The third one, beautiful. I wanted somebody to use something different. Okay? 2. Can we use 2? Yes. Oh, actually good. So Bokan uses 2. Ribs 3. A number of us are using 4. Which one are you using, Bali? 4. Okay. Okay, no, we can't hear you, Nana. Little, we cannot hear you, so your mic is really not working. You can just use your phone. If you log in with your phone, it will be fine. Oh, Noms has given us an answer. 11,48 meter. Oh, thank you. Meters. Now, Bokan's in there. She has locked in now. Huh? Okay, look, we're not done with the question though, so we shouldn't round off. What do you have? 4? 11,475. Okay. All right. Who else? What do you have? 470. All right. 475. All right. Now, we're not going to round off. Whatever you use, just stick to it. Which one should I use? I'll use number 2. What if my time was wrong? But it's okay. Even if your time is wrong, we will give you a positive marking. Okay. So I just use anyone, but I'm glad we all use different one. Vf squared, Vi squared plus 2a delta y. What is Vf? 0. 15 squared plus 2. What's our a? Negative 9,8. All right. Now that will give me 19,6, which if I bring over here becomes 19,6 delta y, 225. If we divide, what are you getting? 11, who used this one? 479. All right. I don't want to round off for now because I'm not done. Whatever you guys did, 475, 47, stick to it. It will all be accepted. But don't round off. Okay. We know how far A has traveled. My good learners, check where we are. I know this as what? 11, do you think we can get how far B has traveled? What do we know about B? Come, talk to me quickly. What do we know about B? Do we know the initial velocity? 0. Do we know the time of travel? 1, Guys, please don't tell me B is now moving down, then you want to change your direction. You have said up is positive. Stick to it. What is your acceleration, which is your G? Negative 9, Please write all of this down and get me delta y. I think we can get delta y. This 7 marks is cheap, man. I want something strong. Yes? Talk to me, Trivo. Talk to me quickly. Yes, do we have a formula? I think I'll use this. Delta y equals to what? Vi delta t plus half a delta t squared. What's your initial velocity? 0. Time 1,53 plus half. Acceleration is going downwards. 1,53 squared. What's your answer? Come on, people, even if I use my head, I'll be done. Huh? You got the same answer? Okay. Can somebody please confirm? You got a negative? Negative. Negative what? 11, 470. I want to ask you a question though. Why are we getting negative? The object B is going where? Down. We chose upward as because those answers must make sense to you. It means it's moving down, but it's only moving down 11, what? 47. Guys, do you think we can get the distance between the two of them now? Absolutely. Distance between A and B would be what? 11,479 plus. Guys, do you notice my minus is not making the calculation anymore? Why? Distance is a scalar what? Quantity. Because we are looking for the entire distance from here. I wanted a highlighter. From here to here. Here is 11,47. Another 11,47. What's your answer? 20. Now we can round off. 22,9. 2 decimal places now. Final answer, 95 meters. We're done. Let me know if it makes sense. Your 7 marks. Let me put ticks. Hold on. I can't see your ticks. I can't see your 1, 2, 3, 4. Okay, where is my last thing in? 1, 2, 3. It's 7, right? 3, 4, 5, 6. Okay, this examiner decided to put. Oh yeah, because we had to create the time for this. Lovely. There's that 1,53 there that needs to be marked. So this mark is for the entire substitution, and this mark is for the time, and that's my 7 marks there. And physics is so beautiful. Do you know, even if you got 50 here, but you use it here, you'll get these 2 marks. It's so beautiful. As long as you see this mark actually, let me put it in the right place for you to enjoy physics. This mark here, okay, come board. This mark is not on the value. This mark is on the plus. So whichever answers you get, but you add them together, you'd get those last 2 marks. Question? Ask?
The acceleration is never positive.
It depends on, okay, there's a hand up there. It depends on your direction, Nana. Let's quickly sort you out. Acceleration due to gravity is always acting where? Downwards. If you choose down as positive, then your G would be positive because it's going down. But we chose up as positive. It means anything going down becomes what? Negative. We're done. Lovely. And don't change that direction. Don't say now B is moving down. You want to change. No. We stick to 1. Let's see. Deruch, talk to me.
Sir, can you go to the question? I want to ask you a question on it.
All right. Lovely. I'll do so. Nolwazi, yes, you get a formula, a mark for choosing the right formula. Okay, Deruch, I'm here.
So, say by VS to VI being short, so we actually said it was 0, so we wanted to put A and B. So then I used the other formula, VS squared equals VI squared plus 2 delta Y, so if VI is VS squared. So then why didn't I get 22,95?
Wait, can you come again because I lost you somewhere? I want to quickly follow you. Let's run. Start again.
So I used my initial velocity to be 0, and then I used my final velocity to be negative 15.
For which object?
So the highest for A was 0, so I used that as the initial velocity. That is the I for B is 0.
Wait, Deruch. I think we're mixing some things up here. You said you used your initial velocity as what? 0. And then for B.
Yeah.
Okay, for B. And your final velocity?
That's negative 15.
For what?
Negative 15.
But we don't know the final velocity of B, by the way.
But isn't it in the same...
No. These are 2 different objects. This A was thrown. B was dropped. So the velocities are not the same at all.
Not like final velocity at the end, final velocity for that position.
For which position?
For where B is.
But B is not here. B is where it was. Wait. Hold on. I think I get where you're mixing things. You see this B at this moment, right? What's happening to B there? Dropped.
Yeah.
No. We are dropping it from that point. So B is going down. That's why the initial velocity of B is what? 0. But the final velocity of B is unknown. We don't know it. We only know that it has traveled for 1,53 seconds. So you bring in this 15. You see this 15 is for A, not for B.
I thought if it's the same position, then the velocity is the same also.
No. Check. A is 15 here, right? It goes up, it becomes what? 0. It comes down, it becomes what? Because it's in motion. But what about B? B was dropped.
But I got the same answer in 7,48 when I used the final measure of 15 and the initial velocity of 0.
No. Wait. You used for which one? Is it the... Okay, look, we have two answers. Is it this one? Your 11,48. This one or this one? For this one?
Yeah.
This is talking about A. That's why I have it as A. Everything here has to do with A. Initial velocity 15, final velocity 0. This particular question has nothing to do, this option rather, has nothing to do with B. Does that make sense to you?
Yeah.
And this one has nothing to do with A, except for the time of travel.
But I thought that the velocities are the same if they like next to each other.
No, next to each other, no. That they are next to each other doesn't mean the velocity. One is thrown and one is dropped. Automatically, velocities are not the same.
So why is it the same?
No, that's wrong. You cannot make it the same. Hence, the keywords thrown means it has an initial velocity of a value greater than 0. Dropped, velocity is that they are close to each other, is just has nothing to do with each other.
Okay.
All right, make sense?
Yeah.
Awesome, beautiful, guys. Quickly, let's draw. What's the next question? Sketch a velocity time graph in your answer book for the motion of A from the time it is projected until it hits the ground. All right, I think that's very straightforward. Let's see. I want to draw displacement. I want to draw velocity. I want to draw acceleration of object what? A. Let's draw A only for now. Let's see quickly. Please don't forget, let's engage. If there's any misconception, let's quickly clear that. Thank you, Deruj. I hope that that is made clear. Okay, so these are two different objects. The only thing they have in common is time. All right, check. Guys, look at my A. A started from here, right? What happened? It went up and then came what? Down. Usually, or normally, this is the movement. It went up and then it came what? It's a vertical motion. But if I draw my graph like this, it means time is not moving. But I want time to move. So if time is moving, what will my graph look like? Check this. This is a sketch. That's a simple sketch of A. By the way, once I do that sketch, do you know what I've done? Displacement time graph. Already done. I'm just going to come here, check. Y-axis, X-axis, and we got this time. What is this time? 1,53. We know this height. What is this height? We got 11, something, right? But now, guys, do you know I don't know what this height is. It's H. It's in the question. We don't know the height, original height of the building. We don't know. But we know that it went up by what? 11,47. What do you think I should write up there? H plus 11, if I'm an examiner, I'll be wicked, shame. Because that's what I'm going to ask you to draw. It went from that height 11,47 higher. So H plus 11,47. Displacement in meters, time in seconds. Are we okay with it? Make sense? What about my velocity? Velocity here is 15, 0, negative 15. Are you aware we don't know that velocity? And we don't need to calculate it. But we know it's going to be higher than 15. How do I draw my graph? Everybody, please check. Your sketch has everything you need. Look at that. What are the velocities we need? If you were here last week, you will notice I'm saying the same thing. What velocities do you see there? I have a 0. I have a positive 15. I have a negative what? 15. And I have one that I don't know. This object started at 15. Beautiful. It went to 0. It came to negative 15. And then to a particular one I don't know. Straight line graph. And we're done. And what time is this, by the way? Which time did it reach the maximum height? 1,53. Okay. All I need to do is to align these things here. And what time is this, by the way, again? When it returned there? 3, and I know this is velocity, meters per second, time, seconds. Velocity, time what? Graph. What did we choose again? We chose upward as, and that would be my, please, this one should be longer than your graph. Your graph mustn't be longer. And that's my velocity time graph. What did they ask us to show? 1 minute. Just want to check something. They asked us to show 3 points. What are the 3 points? Initial velocity, did we show it? Yes. The time it takes to reach its maximum height, 1,53, did we show it? Yes. The time it takes to return to its starting point, 3,06, did we show it? Beautiful. So your graph should look like this. And that's it. Once you are done drawing this, please draw the acceleration time graph for me. Draw the acceleration time graph. Displacement, time. All right. Acceleration time graph, what will it be? What will it be like? We'll run now to another question. Acceleration in meters per second squared. Time in. What was our acceleration, by the way? Negative what? And guys, did it change? And we are done there. Case closed. We don't even know the time. If you like, you can put your 1,53, 3,06. All those ones don't really matter. And I'm done. Acceleration time graph. Huh? Okay.
For this one, I used my maximum point as my definition.
Used?
Okay, no, it's fine. I got this math. It's fine. Check my definition. Okay, so you have an object at which.
All right, are we okay, everybody? Let's run. Let me see. Is there any other question that needs to be dealt with? Is it possible to calculate it? Yes, it's possible. We can get VF. That's very easy to do. Very easy to do. Is it possible? Is it possible? No, because we don't have the height of the building and we don't have the final time. So in this case, it's not. All right. But before we go ahead, Nompi, I've answered your question. Guys, quickly, let's do something here. We did this last week. I want to run away from this. What shape is that? It's a triangle. What's that? What's the area of a triangle? I wanted to see something. Half base times height. What is the base? 1,53. What's the height? 15. Please put that in your calculator. I want to shock you. You're going to get a number that we got today. Huh? You can't get 22. You're supposed to get 11 point something. 11,47. Yeah. Did you put half? Yeah. 11,4. Do you remember that value? That was the maximum height. Check here, my good learners. If I call this point P, point Q, point R, and S, let me label that point. Point P, point P, point Q, point R. Do you notice that PQ is the maximum height? PQ. Whatever distance I get there represents maximum height. This is examiner telling you without the use of what? Equations of motion. Please, lesson 3, we spent a lot of time on that. The area will give you displacement. Please, go back to lesson 1. And I think more of that was done in lesson 2 and 3. The area of a velocity time graph would give you displacement. All right, we have another question. Let's run quickly. 2 objects. Did you do this one? But it didn't make sense. Huh? Okay. All right, let's look at this question then. I think after this, we'll quickly get to what? Let me see. I think it's a hot air balloon. Let's see if we can do. Oh, beautiful. We're using the same. I should change my file because you're doing all of this at school. I'm not enjoying it now. But they are lovely questions. Okay, guys, quickly look at this. Ball A is projected vertically upward. Please look at the definitions again. Projected vertically what? Upwards. 16 meters per second from the ground. Ignore the effect of air resistance. Use the ground as what? 0. Number 1. Calculate the time taken by ball A to do what? Return to the ground. Can you do that for me, guys? You have just 2 minutes, please. Ball A went up. And then it's exactly similar to what we did earlier on. What would you choose? For me, I would choose upward as positive. It means I know my initial velocity as what? 16. What's my final velocity? Negative 16. Case closed. Choose your direction. Quickly, everybody. You still have the formulas? Okay, do we have everything we need? Because I don't want to tell you the formula. You must know. Here is our starting point, and that's our stop. So that's going to be our initial. Choose your direction. Know which A you are using. Are you using positive or negative? Because you chose upward as positive. All right, quickly. Here's the formula page. Let's get it done quickly. I won't spoon feed you. That's the formula page. All right, Nompilo says 3,27. Those of us at home, we're not sharing answers. Come, let the answers come. Thank you, Adeze. I need everybody participating. Please. We all need to participate. Can you confirm that answer? Because I'm not going to do it. Sorry? 1,63. What's your final velocity? That means you calculated to the maximum height. Do you understand what I just said? You got to the maximum height, but this object returned to the ground. So your 1,63, you should multiply by 2. Where's that charger? Multiply that by 2. So you are using option 2. Confirm answers? All 2? Wrong. Seconds, correct. Yeah, when I do that, you'd remember in the exam to put that. We get people who do all of those without units and they get answers wrong. Are we okay now, Bonolo? All right, so please take note. 3,27. All right, thank you, everybody. I'm sure. Let me know if you're not getting that 3,27. It's basically your final velocity, 3,27. All right, everybody sketch a velocity, 3,27 seconds. Sketch a velocity time graph for me of object A. Show the following on the graph: initial velocity of A, time taken to reach its highest point, and time taken to reach. Similar to what we did. Initial velocity. Thank you, Amatle. Amatle, please put units. Thank you, Gift. Let's get used to putting units. Very, very crucial. We should be done drawing, guys. Okay, okay. All right. What's your graph looking like? What's your graph looking like? Your graph should be looking like this. And let me know if you have this exact graph. What's the initial velocity again? 16, right? Then you have 0, and then you have negative what? 16. What was that time you got again? Time? Eh?
The final one.
Yeah, whichever one. 1,63. 3,27. Time here in what? Seconds. Velocity. Please label this. And this is a velocity time what? Graph. And what did we choose? Upward as positive. That's your complete graph. Let me know. Are we okay? Guys, does it look like this? Let me know, guys. Is your graph looking like this? Quickly, quick response. Sir, do you have to choose downward as... No, you don't have to. You have a choice. You can change. You can decide to use downward or upward as negative. Then your graph would have to turn around. So if you use that direction, upward as negative, your graph would look like this. It means your initial velocity is negative 16, 0, and positive 16. For me, that's why the sketch is very, very important, and your direction. Are we okay? All right. Next question, quickly. 1 second after ball A is projected, a second ball B is thrown vertically downwards. Please, I need us to read to a point of understanding. Somebody said, there. Is it a question that's making you sound? 1 second after we did that last week, it means time is less by 1. 1 second after ball A is projected upwards, a second ball B is thrown vertically what? Downward at the speed of what? At a velocity of 9 from a balcony 30 meters above the ground. Refer to the diagram. Calculate how high above the ground ball A will be at the instant the two ball passes each other. Okay, let to breathe. The first thing you need to do here is pause and read again. 1 second after ball A is projected upwards. Okay, hold on. What does that mean? We threw ball A upright, waited for 1 second, then we threw ball B down. Okay, so ball A is going up and ball B is moving where? Down. All right, from a balcony 30. Calculate how high above the ground ball A will be at the instant the two of them would pass what? Each other. Can I create a quick sketch for you? Let's see. What will my sketch look like? What would I do with this question? With a very simple, I don't want us to waste time. We have another free fall. So look at this. We have a height. Ball A was thrown where? Up, right? Ball A is going up and ball B is coming where? Down. At a particular point, they actually pass each other. Make sense? That's logic. The question is, how high is ball A when these two objects actually pass each other? We want to find, when I say height, height is always measured from the ground. Change, man. Green. Okay. Lovely. This is the height I'm looking for. Let me know if my interpretation makes sense before we even start the drama. Give me a thumbs up if my interpretation makes sense to you quickly. They pass each other at a particular spot. We don't know. Always check there. If somebody gives me a thumbs down, let me know. All right. Guys, what is the height of this building? 30 meters, right? What do you think? If this is h, what is this? Does that make sense? 30 minus h. What direction did we choose? Upwards as positive. So it means that, so we chose upward as the initial velocity of this is what? Positive what? 16. What is the initial velocity of B? Negative 9. Why negative? Because it's, can you see I'm not changing my direction, I'm maintaining the same thing. But B is coming where? Down. So initial velocity becomes what? Negative 19. Are we good? Lovely. All right. We're almost done. What is G, by the way, for this entire story? Since we chose upward as positive, G is always acting where? So what is my G? Negative 9, comma. Are you with me? There's somewhere I'm going to lose you. And I want to try not to lose you. What is the displacement of B? The displacement of A, we call it H. Because it is going upward, it is positive. The displacement of B is coming where? Do you remember the first question we did where we got a negative answer? And we said the object was moving what? Good. It means this answer, B, is also moving what? Down. My answer should actually be what? Negative. I don't know if that makes sense. If that makes sense, then we are done. Please talk to me. Let me know. If that makes sense, then this is why direction is key. The only thing you don't give direction to is time. Other things, A, VI, VF, delta Y, you must give it time. Why is that negative again? We chose upward as positive, downward as negative. So delta Y of B is negative. Does that make sense? If that makes sense, let's jump into calculation. It's going to be a bit lengthy. What do we know about A? Let's write the things we know about A quickly. What's the initial velocity? 16. What is the displacement of A? We said let's call it what? H. What is G, by the way? Or A? Are you aware that we don't know the final velocity? But throughout the question, something was mentioned. Time. 1 second later. Wait. Can I call the time of A? Let's call it TA. What will be the time of B? TA minus 1. It's 1 second late. I think we did that last week as well. Spent some time. Do you understand why we say minus 1? Because B was thrown 1 second. So if A had traveled 5 seconds, B will then travel 4 seconds because it was thrown 1 second later. Thumbs up, thumbs down quickly on the time because we are then done. Once you see, guys, I'll tell you your problem. Already you read that question, you started there. Why did no? Analyze. Somebody's saying, but you're spending so much time analyzing. Yes. If I start calculating now, it's wire. I'm not going to stop. Okay, so I have my delta T of A as TA. Guys, do I have a formula? Please write that down. I want us to pick a formula quickly. I have VI, delta Y, A, and delta T. Is there a formula? Let me do this so that we don't keep moving. Look at this. All right, guys, here's my formula page for you. Which formula would you use? Which formula has everything that you think you need? Looking at this. Which formula? We said 1, 2, 3. Which one? I think the third one, right? Because there's delta Y, there's VI, there's delta T. Okay, so let's bring that in. Delta Y, I'm going to run with my calculation now, equals to VI delta T plus half A. Okay, what's my delta Y, by the way? H. What is my VI? 16. What is my T? TA. We're good. Plus 1 over 2 negative 9,8 TA squared. Oh, beautiful. What do we have? H 16 TA negative 4,9. Guys, do you notice I have 2 unknowns? Once I see 2 unknowns, I'll stop. A simultaneous equation is somewhere. Does that make sense? We're not even forcing. Yes? No. Good question. And that's what you guys do again in the exam. What was that 3,26? Let's put our mind to this question now concerning that 3. So the 3,26 was it returning. But right now we don't even know when it got here. It hit the maximum height and then turned back. We don't know the time here. Good question. Because many people just force that time in now. So we don't know the time we're stopping. Guys, what do you know about B? Talk to me. Give me information. What's your initial velocity? Negative 9. What is your delta Y of B? Negative 30. Are you there? Can we simplify this? Does that make sense? I've multiplied in already. All right. What else? What is A? What is the time for B? It is TA minus 1. Are you aware that it's the replica of what we have? So we can throw in the same formula. Can we throw in the same formula? Beautiful. What are we going to have? Delta Y equals to what? VI delta t plus half A. All right, let's run. What's our delta y? H minus 30. What's our initial? Negative 9. Remember, this is TB. What is TB, by the way? TA minus 1 plus half. What is A? Negative 9, 8. What is TB? TA minus. Guys, we are done with physics. It's now the job of your math teacher, whoever your math teacher is, to deal with this. Can we do it together? Because of our time, let's do it together. Guys, let's do it softly and easily, enjoying maths. What is H? Do you notice I have H? What is it? 16TA minus. Do you see that, right? I can bring this there. All right? Because of space, I'm going to move a bit down. So what would it be? 16TA minus 4,9 TA squared. Are we there? Minus what? 30. Ooh, I need a lot of space. So guys, please follow. Let me rule a line here. And rule a line here. The rest, like I said, is just maths now. Are we okay with that first step? Let's expand. What are we doing here? Distributing. What will it be? Negative 90A plus 9. Half of 9,4, 9,8 will give me what? 4,9. Minus 4,9. What are we doing there? Foiling. What would that be? TA squared minus 2TA plus, I hope you understand what foiling there. Is that correct? Yes. Because it's TA times 1 times 2 foiling. Did I lose you? Okay. Let me know if I'm losing anybody quickly. Can we simplify all of this? What are we going to get? 16TA minus 4,9 what? TA squared. All right, let's expand quickly. Minus 9TA plus 9 minus 4,9 what? TA squared plus 9,8TA minus, are you there? Guys, look at the beauty. If I take this thing here over to this side, what does it become? Do you see it cancels each other, right? Lovely. So can we skip that? Let's bring all our t's to the left. What do we have? 16TA plus 90A. What other t do we have? Minus 9,8TA. Are you there? Let's put our numbers to the right. What do we have? This negative 30 becomes what? Positive 30 plus 9. All right, bring out your calculators, everybody, and get me TA. Basic grade 8 now. All right, let's see. I need a final answer. Michelle is giving me 2,24. Are we all getting that? 2,24. It's just basic maths now, right? We add. I think Pluto, you were giving me that TA, and then we divide. If I have my time, do you know I've gotten the height? If T is 2,24 seconds, what do I need to do to get the height? Substitute back there. I get my height. And we are done with the 6 marks. So my height will be 16, 2,24 minus 4,9, 2,24 squared. Ribs? Make sense? Guys, it's the direction that causes problem in such questions. When people don't take direction, then we have a problem. Beautiful question. Lovely question. Somebody giving me time? Oh, you guys are still giving me time. Give me that height now. We finished physics there long ago. We're just dealing with maths. What am I looking at? All right, please give me the height. I'm waiting. What's your answer, guys? 11,25? Nolwazi give me 11,23. Michelle give me 11,25. What do you have, guys? Why are we getting different answers? 11,25. 11. Thank you, Tlotlo. 11,25. Adeza. Nolwazi, why do you have a 2,3? Check your calculations. 2,5, right, everybody? Okay, it's closed. We are done with that question. 11, guys, I don't know if you see that once we started, it became easier to calculate once you do your analysis. So if you need to draw a fresh diagram, draw, sketch, write out your velocities, but maintain one direction. If you choose up as positive, down becomes what? Negative, and you're done. Let's go to a hot air balloon now, quickly. Hot air balloon. We should be able to do that for the rest of the day. And yeah. Let me know. You still have a calculator there too? What are you getting?
So I was just checking for answers.
Okay, but you're okay. All right. Let me know if there's any question. Let's see this one quickly. Well, maybe I'll do a few more other things that you guys did not talk about in class, because I know you did this in class now. All right. I might just talk about a few more things, which I think I usually do. 1 second, just to make it a bit smaller. All right, guys, a hot air balloon. A hot air balloon is rising vertically at a constant velocity. First question, is a hot air balloon a free fall? Why not? Huh? Talk to me, because it's not, it's going up, right? Yeah. Is it a free fall? Okay, Noluazi, your TA was not rounded off. All right, okay, it's fine. Gravity is not the only force acting on it. How do you know, Michelle? Here's the key. Yes, it's not a free fall. Guys, when I hear the word constant velocity, what is acceleration? And for an object to be a free fall, what should be our acceleration? Does that make sense? And that is enough reason. They said it's moving at constant velocity. Something is pulling it down, right? As it's going up, the velocity should actually be decreasing. But it's keeping it what? It means there's a force. It's like when you're driving a car. Okay, you guys don't drive, so let me use that example. Who drives here? You drive. How well do you drive? Very manual or automatic? Manual. Okay. These other ones, their hands are in their pockets. In your heart, you drive. Clocky, yeah. And it's lovely. And you don't have an accident, right? And when you drive in your heart, you can even jump, you know? Yeah, you look at there's traffic here. In your heart, you're already on that other side. Well done. All right. Now, if you are driving up the hill and you don't accelerate the car should start coming down. What makes you keep the car up the hill? You accelerate. And once you accelerate, it's no longer a free fall because you are putting power into it. So for a free fall, our acceleration has to be what? 9,8. All right. I hope my explanation makes sense. Constant velocity, acceleration is 0. Okay, let's see. No, there are other forces acting upon it. Good. Force of the engine. Thank you, Adeza. All right. Okay, quickly. When the hot air balloon reaches point A, a few meters above the ground, a man in the hot air balloon drops a ball. Guys, please listen. I told you I'll come back to this. When we started that first question, object B was dropped. Do you notice we are dropping another object here? But their initial velocities are not the same, although we said dropped. Check. That first question, we dropped from a stationary point. What's the initial velocity? 0. Guys, are you aware that if this hot air balloon was moving at 20, everything in it is also moving at 20? Guys, if you are sitting in a car and your father passes by KFC, yes, you are hungry. They drive past KFC at 100. Now you passed KFC at 100 because it's to go. So if you are in the car, you are also what? Moving at the speed of the car. Does that make sense? So anything inside the hot air balloon is also what? Moving. Hence, that ball that was dropped wasn't 0. It was moving at the initial velocity of the what? Hot air balloon. I quickly want to sort something out there, and I did it last week. I'll do it again. Guys, how will my object move? The object will first move up before it moves down. Why up first? I mentioned it last week. Newton's first law. An object will remain at rest or continue in uniform what? Motion. What was the motion of this hot air balloon? Up. So when we drop this ball was also moving where? Up. So it's going to move up first before starts moving where? Down. Please, that's very, very important. And I'll show you from this graph. Okay. All right. Quickly. The VT graph below shows the motion of the ball from the instant it was dropped until it bounces for the first time. Also, it bounces. I'll show you all the bounce. The time interval between bounces is ignored. It means it bounced off immediately. We did that last week again. All right? Last week. The upward direction is taken as... In fact, this examiner is kind. Usually, they won't tell you this. This examiner is spoiling physics for us. I don't know what's wrong with them. That's not supposed to be given. Please. This examiner is spoon feeding you. I want to ask you a question. Do you think I can determine the direction from the graph? We can. How? I told you last week. I keep mentioning, guys, lesson 3, too important. This is a velocity time graph. The gradient here is g. Do me a favor. Let's call this point x and point y. Please, can we calculate the gradient between these 2 points? Let's just quickly do that favor. Gradient, we say y2, right? Minus y1 over x2. I want to quickly show you something here. What's my y? 5,88. Second y, 0. Right? Okay. Which one is my x2 and which one is my... Let me show you. Let's call this point 2 and let's call this point 1 for clarity. What is my y2? Y at point 2. This is point 1. Y is 0. What about x2? This is my point 2, right? What is the x value at point 2? 0. And what is my x value at point 1? Please put this in a calculator and tell me what you get. What are you getting? Please, it's not a coincidence. It is not the gradient is what? Acceleration due to gravity. And that's why these 2 lines are parallel to each other. Both gradient. Analytical geometry now. If lines are parallel, gradients are what? Equal. Now, my good learners, please check. I want to show you the direction. We got this as what? Negative 9, what? 8. Can you see analytical geometry? But G is always acting where? Look at this. What have I done now? The examiner took down as. So the examiner took down as negative. What is up? Positive. So they will not tell you. This one is just, I don't know what, maybe they gave him 100 rand before he said this paper, and then he decides to just add these things. Normally they don't. May this type of examiner set your test. May they locate you by force, by fire. I'm the one setting. So they will not, but did it make sense? This is you understanding graphs. My gradient, you can see already 2 things. It's a negative gradient. And this gradient is acceleration due to gravity. It's a negative 9,8. And G is always going where? So down has been taken to be negative. Are we okay, everybody? All right. Okay. Another thing before I look at these questions, everybody, let's call this point A. Oh, I changed it. It's fine. Point B, point C, point D, point E, and point F. Please look at this. I want you to enjoy physics before we even jump into calculus. These calculations are so easy once you understand the whole story. What is the velocity at A? 5,88. What is the velocity at B? 0. Wait, when will the velocity be 0? Lovely. I don't know if you see something. This is now my A. I want to just make you see something here. And I'm going to give you another direction, another dimension. We chose down as what? Negative. Looking at a graph, do you see that this is negative, right? Okay. And we chose down. It means on that side, this is down, and this is what? Between point A and B, what is it? Look at my graph on the right-hand side. A and B. Everything is just coming to play. Object is moving where? Up. I don't know if it makes sense. Because if you understand this, you just be laughing that, these guys. Your velocity time graph must be accurately converted to a displacement time graph. So between A and B, it's positive. And we said up is, that means the object is going where? Up. It reaches point B, maximum height. Wait, do you notice B and C? What's happening? It's a negative. Object is moving what? Oh, lovely. Where's my C? Hold on. Let's come back again to the graph. Look at D. Between D and E, it's positive, right? Object is moving where? Do you notice E? Velocity is 0. That's the maximum what? But the time between C and D, it's exactly the same spot. Oh, sweet physics. So this is C. This will be C, and this will be what? Now what happens? Object goes where? Up. And this is point what? E. Between E and F, what's happening? It's a negative. Object is going where? Down. Check something again. Do you notice the velocities? It means it's at the same level. If this is my D, E, that would be my F. Guys, if the examiner were to ask me to draw a displacement time graph, I am actually done. My y-axis and I'm done with my displacement time graph. Please let me know if it makes sense. 10 minutes we jump these questions. Please talk to me. Did it make sense? Analysis. Right now when you are practicing at home, when you see a graph like this, try to interpret it this way. Put letters and draw. Yes.
What would happen if
If
the ball stopped?
the ball stopped for a few seconds, lovely question. C and D will not be on the same line. Then my graph would have looked like this now. How would the velocity time graph? Okay, beautiful question. How would the velocity time graph? Oh, I just enjoy physics. I don't know which one I enjoy more, physics or EC Zulu. I don't know. What would my graph look like? Check. Now we are going to do something here. This time it reached the ground, but it did not bounce off at the same time. It stayed on the ground. And we'll have that now. So this gap here tells me object is on the ground. Are we okay? Please, it's important because when the examiner gives you a graph, they can mess you up. Okay, let's jump. Write down the magnitude of the velocity of the hot air balloon. Wait. This whole thing is about the object. What is the initial velocity of the object? That is simply telling us the velocity of the hot air balloon. So the hot air balloon was moving at 5,88. When the object dropped, the velocity of the object is the same as the velocity of the hot air balloon. If you are in a car, the car is moving at, you can't say this guy wants to kill us. For me, I'm going to drive at 20 meters per second in my heart. Reportedly, that drives in a heart. That is this driver. Or you are late for school. Do you notice the day you are late for an exam is the day the transport starts misbehaving? You can't say, Mara, this driver, I need to be in school. So in my heart, I'm driving at 100 and the guy is driving at 20. Okay, your heart doesn't work there. Make sense? So the object will have the same initial velocity. Make sense? So what's my first answer? 5,88 meters per second. I can share this question with you. Or just remind me, I'll share that whole file. We can start practicing. I'll share a whole file with you. So, number 1, 5,88. There's no need for direction because they said what? Magnitude. Second question. Calculate the height above the ground. Oh, beautiful. I love this one. Guys, I can use my graph, the one I sketched, or I can also use this graph. Let's use the one that we sketched. I want us to see something. Let me resketch it here for clarity. So I took you through all of this sketch. Object went up first, right? It came down. Are we there? We call this point A, point B, point C, point D, point E, end. But I want to write my velocities. What is the velocity at point A? 5, what? 8, 8. What's the velocity at point B? 0. What is the velocity at point C? Negative 19, what? 6. Do you know why it's negative? Upward is chosen as. Good learners, what are we looking for? Talk to me. The height above the ground with which the ball was, from which the ball was dropped. Height above the ground. Please use letters to tell me which height we are calculating. A to B, B to C, A to C. Take you back to the question. If you don't get this one right, we cannot calculate. Calculate the height above the ground from which the ball was dropped. You get the question? A to B, B to C, A to C. Huh? Come, let me get answers from those at home. Talk to me. Yes, while they are writing, they are typing, because it takes long to find letter A and B. What's your own answer? A to C. I'm not mentioning M. You see, I've changed. Thank you.
So I'll say A to B, but I'll say A to C.
Why do you want to say A to B? Why are you not saying it? Say, just say it. A to B. Okay. A to C. A to C. B to C. Okay, B to C. A to B. A to C, everybody else. Guys, oh, those at home, what's going on? I need responses quickly. Please, 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 please. We're running out of time. Read the question again. Calculate the height above the ground. So we're looking at the ground from which the ball was dropped. Where was the ball dropped? A. Where's the ground? Done. So we're looking for A to C. B to C would be the maximum height reached. Make sense? So this is where the object was dropped, and that. Can you tell me what we have, everybody? Quickly, let's run. Like we usually do. What are the things we know? We know the initial velocity. What is it? Between that A and C, do we know the final velocity? What's the final? Negative 19,6. Do we know acceleration? We are choosing upward as positive. So what is A? We are looking for delta what? Y. Is there a formula? What's your formula? You still need the formula page? Oh Lord, guys, you are using this formula for 3 years. A department is spoiling you guys by giving you formulas. My first year when I was teaching, I didn't give those kids formulas. They came to fight me from the department. It was a serious fight. Department came. Like, where's the formula page? I said, they must know it off by heart. What do you mean? No! I said, ma'am, can you just go back to your office? Those kids, they got formula page at the end of the year. They didn't even need it. You want to use a different formula? The fourth one. Oh, yeah. Guys, we know the time between A and C as well, right? From the graph. Beautiful, Ribotlet. Lovely. What's the time between A and C? 2,6. So we can actually use number 2, number 3, and number 4. Do you agree with the time? Guys, do you see that my letters are very important? You have to use letters. Quickly get me an answer, because I want to do something different. I want to add to the options you have. Everybody. Those of you at home, please, I need you to respond so that I can see where we are. Only Adiase. Am I pronouncing it well? In my head, I'm seeing Adese. Daisy, where did I get the time from? Quickly, between A and C, look at it. 2,6. Between A and C, 2,6. Daisy, we okay? Quickly, everybody, work this out for me. I want us to finish this. Okay, while you are busy with that, guys, I'm not going to calculate, so I need you to get it right for me, please. And this is 0,6 there. Anybody done? Quickly share answers with me. 17,84. 17,84 meters. Okay. The height. If I say height, you don't need to give me the down because height is always all right from the ground. Okay. Can we confirm this? You got a negative answer? Oh yeah, makes sense. Because the object is coming where? Down. All right. So your delta y will be what? Negative 17,84. But the height is 17,84. Because if I ask you for your height, you measure it from the ground. Guys, can you confirm this for me, please? All right. Lovely. You got that too. Okay. Who's still busy? Quickly, quickly. What did you get? Okay, because your eye is rolling. What were you looking for? Oh, sorry. But guys, I want to change that question that we just did. And listen to my question. This is the kind of examiner you're going to meet. Without using the equations of motion, calculate the same question. Guys, it is A to C, right? Did you get it, that answer, 17,84? Yes. Okay. All right, please look at it. Without equations of motion, the examiner wants something. This is point A, point B. Draw shapes, but use the x-axis as your base. Do you notice? There. X-axis is my base. What about between B and C? Using the x-axis as the base. This x-axis will always be your what shapes do you see there? Triangles. What's the shape area of a triangle? But how many triangles do you see? All right. Half base times height plus, look at what I'm going to do quickly. What is the base of the first one? 0,6. What is the height? 5,88. What is the base of the second one? Do you notice this base is 2? It's 0,6 and 2,6. What's my base? 2. What is the height of the second one? Negative 9. Please put this in your calculator and tell me your answer. So when they say without equations of motion, all you need to do is to find the area. Take note, there are questions like that. Without equations of motion, what I need to do is to find. Sorry, sir, I am unable to hear you. Why not? Guys, can you hear me? Make sure my sound is fine. Check your side quickly. Ooh, are we going to finish this question? My sound is fine, Michelle. So please put a note down for yourself. Area is what? Displacement. The area under a velocity time graph is displacement. Bernard, what's up? Did you get it?
Yes.
Okay. But this one, did you get it?
No, I didn't get this one.
Quickly, we're going to move to the next question. Please, let's read. Ooh, it's already time. And I have 3 questions. Oof, I don't want to rush you. Do you see that? Put it in bracket. It will change all your answers. All right, guys, I don't know. Time is up. I have 3 questions to... that these questions will take me time. But look, if you understand what I did here, guys, somebody should take a picture of this, send to the group. I want to see how you can further interpret this. I have actually answered almost all of these questions while explaining. Calculate the time at point P indicated on the graph. That one is very easy. It's the midpoint of these two. Do you notice P is, that's E, right? The time it takes the object to go up is the time it takes to come down here. How do you get a midpoint? Add these two together and divide by what? 2. What is 2.6 plus 3.8? 3.2, that's 5.8. What is 5.8 divided by 2? That's 2.9. Done. We're done with that one. P is 2.9. 2.9 seconds. I'm just going to explain the rest. I won't do, let me see if I can just touch it. I won't really do it. Calculate the maximum height the ball reaches after the first bounce. Where's the height after the first bounce? The object bounces here, right? Where's the height it reaches? E. So you are walking between D and E. Done. Do you have the velocity at D? Yes. Do you have the velocity at E? Yes. You're done. In fact, no story. I can simply look for the area of that tiny little graph, because area will give me what? Displacement. Or otherwise, I know my initial velocity, I know my final velocity, I know the time. If this is 2.9, what's the time there? 0.3. Did I lose you? I might have lost someone. Quickly, I'm out of time. Look at this. This is what I just explained. I have this. I have that. Okay, I'm going to skip all of those other things. We're working here. Right? What was this time again? 2.6, right? And what is this time? Are you aware that if you could actually subtract, what is 3.2 minus 2.6? That's what? 0.6. And this is exactly halfway, which is 0.3. It makes this what? 2.9. This is your D, that is E. So what's the time from here to here? Make sense? 2.9 minus 2.6. So we can calculate the maximum height there after the bounce. Lastly, Okay, this one I'll come back and do this one. This one needs you to be fresh. So guys, what's going to happen is next week, I think let's do this. I'm going to use my first hour to do this, then I'll start chemistry in the second hour. Because I want to look for more questions. You know, some of us think we are done until the question sharpens us. All right, so I'll do 3.5 first hour and add 1 or 2 questions. I'm going to pick a different file now, Ribotile. I'm just saying, so that you enjoy variety as well. And then, after my first hour, I will introduce organic what? Chemistry. We will catch up with your schools, don't worry, and get it sorted. All right, guys, lessons are available on the group. I'll reshare the link. All right, I'll share this question. Somebody just screenshot this and send it on the group, please. It's easier if it's screenshotted. Have a lovely evening. Somebody screenshot, please, and send on the group. But I will send some more files for you that you can use for practicing. Have a beautiful evening. I know your head is hot. Just go get some water and drink. Good night, everybody, and much love for physics and you.